Okay, moving on to question 9. We have this reaction scheme question where we are supposed to deduce what are the formula for R, S, and T as the intermediate products. So first of all, this tolerance reagent, we know that it's a test for aldehyde. And as a result, S must contain an aldehyde functional group. So it must be a RCHO, and T must therefore be a RCOO minus, because the aldehyde undergoes oxidation by tolerance reagent to form a carboxylate. So let's take a look whether any of these can be eliminated. So COO minus, COO minus, COO minus. It's quite evident that C is wrong because C has a CHO for T. S must be a CHO, so CHO, CHO. So again, in this case, we can cancel away option D because D is a ketone, right? Methyl ketone. And of course, this is also wrong, right? So C and D are obviously wrong. And now, if you take a look at it, how is S formed from R? R, it's oxidized. How do we know it's oxidized? Because of the conditions of acidified dichromate. Again, it's an oxidation reaction. This will imply that R must be a primary alcohol. So primary alcohol undergoes oxidation to form, well, aldehyde. So again, in this case, you again have a primary alcohol. So now, the only difference between A and B, if you can see clearly, is now between the compound T, right? So let's take a look, all right? R and S are identical. So what's the difference between S to T? In this case, S from 3 carbons becomes 2 carbon, whereas in this case, the S is from 3 carbons to 3 carbons. So it's quite obvious that tolerance reagent is just an oxidation reaction. There's no decrease in number of carbons. So B will be the correct option. There's no decrease in carbon. There's no step-down reaction. Alright, so therefore answer should be B. It shouldn't have a decrease in carbons like what you see in A. Okay, so those of you who wants a clearer answer, this will be likely the reaction. Primary alcohol becomes your aldehyde, and then your aldehyde becomes your carboxylate with tolerance reagent.